Welcome to Sleepless Scientist, the channel where science speaks in whispers, not roars, to help you relax, ease into sleep, or simply get lost in the wonders of the universe without being jolted by sudden plot twists or loud sound effects. Tonight, we're diving into something so vast, so hot, and so profoundly essential to life on Earth that we often take it for granted. Yes, tonight we're going to talk about the sun, the giant glowing orb in the sky that does more than just light up our day. This isn't just a story about sunshine and warmth. It's the tale of how the sun, each day, keeps Earth not just alive, but perfectly balanced between fiery chaos and freezing desolation. Thank you for choosing to spend time with this video. If it disrupts your rest or makes your thoughts too lively to sleep, I sincerely apologize. But if you find your curiosity blooming gently under the stars, please consider liking this video, subscribing to the channel, and leaving a comment with your current location and local time. It's always wonderful to see how far the light of science can reach. Now, let's follow the light. The sun, a sphere of plasma so massive and so incomprehensibly hot that it would vaporize everything within millions of kilometers. And yet it hangs peacefully in our sky like a serene morning lantern. This flaming behemoth is about 109 times wider than Earth. If Earth were the size of a basketball, the sun would be a sphere the size of a small house. It contains over 99% of the total mass in the solar system. That includes everything: planets, moons, asteroids, all of it. Everything else orbits this one central figure. We dance because it tells us to. Every second, the sun emits energy, equivalent to about 1 trillion megaton bombs. And yet, from our safe distance of approximately 150 million kilometers, or 1 astronomical unit, as astronomers like to say when trying to sound impressive, that energy is diluted into a golden warmth that nourishes forests, melts snow, and gently wakes us from sleep. The sun is not a solid object. It's not a burning ball of fire, despite what ancient myths or well-meaning cartoons might say. It's a churning, boiling ocean of ionized gas, mainly hydrogen and helium, held together by its own gravity. Its heart, the core, is a region where the pressure is so great that hydrogen atoms are crushed together to form helium in a process that releases colossal amounts of energy. This reaction, nuclear fusion, is what powers the sun. Each second, the core converts over 4 million tons of mass into pure energy. That's right, mass transformed into energy, following the deepest secrets of physics. Now, how does all this fiery chaos help us? For starters, it brings light. But light is more than just what helps us see. Light from the sun is made up of photons, tiny packets of energy that travel across space in about 8 minutes and 20 seconds before reaching Earth. These photons carry not just warmth, but also vital information, energy, and patterns that our planet depends on. The very rhythm of life, the circadian rhythm, is tied to the daily cycle of light and dark. Sunlight stimulates the production of vitamin D in our skin. This humble vitamin supports the immune system, bones, and countless other biological functions. Plants use sunlight to photosynthesize, converting solar energy into chemical energy, producing oxygen in the process. One tree can absorb as much as 22 kilograms of carbon dioxide a year and produce enough oxygen to support 2 people. That's not magic. That's sunlight converted into a living process. Let's linger a bit on the process of photosynthesis. In the green factories of chloroplasts, plant cells capture sunlight and use it to combine water and carbon dioxide into glucose. This glucose feeds the plant, builds its structure, and stores energy. In doing so, the plant releases oxygen. Without the sun's light, this entire mechanism would collapse. No plants, no oxygen. No oxygen, no animals. No animals, no humans. The sun is not just a warm lamp in the sky, it is the engine that powers all ecosystems. Consider agriculture. The crops that feed billions across the planet grow only because the sun provides enough energy to allow seeds to germinate, leaves to stretch, and fruit to ripen. A single square meter of Earth's surface receives around 1 kilowatt of solar power in full daylight. That's more than enough to run your blender, your lights, and your microwave all at once, if only you could. Capture it as efficiently as a leaf. And yet, despite all this generous energy, only about 49% of it actually reaches the surface of Earth. The rest is reflected back by clouds, absorbed by the atmosphere, or scattered into space. But even that fraction is enough to drive global wind patterns, ocean currents, and weather systems. The sun powers the monsoons that irrigate rice fields, the winds that push desert dust across continents, and the snowmelt that fills rivers. Now let's turn to temperature. The sun's warmth is what keeps Earth from becoming a frozen wasteland. Without the sun, the average temperature of Earth's surface would plummet to -18 degrees Celsius, or 0 degrees Fahrenheit. That's below freezing everywhere, all the time. The oceans would ice over, the atmosphere would begin to collapse. Life would become an archival entry, not an ongoing process. Instead, thanks to the sun, our global average temperature sits around 15 degrees Celsius. That may not sound particularly impressive, but it's just right for maintaining liquid water, the essential solvent of life. Water remains stable over a wide range of temperatures and supports the complex chemistry of biology. Without the sun, there would be no rain, no rivers, no clouds, no hydrological cycle. The poetry of water would fall silent. The sun's energy also drives evaporation, lifting water vapor into the sky, where it condenses into clouds and eventually returns as rain. This continuous cycle replenishes lakes, nourishes fields, and supports forests. A single oak tree can transpire over 300 liters of water a day during summer. That's a living fountain powered entirely by solar heat. But perhaps the most beautiful aspect of the sun is how it brings rhythm to existence. Day and night, summer and winter, solstices and equinoxes, all these temporal landmarks are dictated by the sun's presence and apparent motion. The tilt of Earth's axis means that sunlight falls differently across the planet throughout the year, giving us seasons. In the northern hemisphere, the sun's lowest point marks the winter solstice, while the highest gives us the summer solstice. Entire cultures have risen and fallen by tracking the sun's cycle, planting crops by its rise, celebrating festivals by its decline. Even animals are guided by the sun. Birds migrate using solar cues. Insects like bees use the position of the sun to navigate back to their hives. Some flowers open only in sunlight and close at night. Humans, too, have internal clocks deeply tuned to solar patterns. When you feel sleepy at night or wake up naturally at dawn, you're obeying signals that started in the heart of a star 150 million kilometers away. So much of our daily experience is quietly sculpted by this blazing giant. The morning sunlight that warms your face is the last echo of a journey that took millions of years. You see, the energy generated in the sun's core doesn't just leap into space. It takes between 10,000 and 1 million years for a photon to travel from the core to the sun's surface, bouncing and ricocheting off particles in a dense, chaotic dance. Only once it escapes the outer layers does it fly straight to Earth, in just over 8 minutes. That warm ray that touches your skin today might have begun its journey long before humans even built cities. And yet, despite its age and power, the sun is not immortal. It is currently about 4.6 billion years old and has enough hydrogen to continue shining for roughly another 5 billion years. It's in the prime of its life, stable and reliable. But one day, it will change. That story, though, is for another time. For now, know this: each moment you spend on Earth, whether you're watching clouds drift, enjoying a breeze, or walking beneath a canopy of leaves, is a gift handed down by the sun. It doesn't demand thanks, but it does deserve awe. Every heartbeat, every breeze, every falling leaf owes something to the persistent, invisible threads of energy stretched between our planet and its solar parent. The sun may be 93 million miles away, but it touches everything on Earth. Not with hands, but with light, warmth, and rhythm. And while its effects on the grand scale are impressive, shaping climates, feeding ecosystems, sculpting landscapes, it's just as important to explore how the sun influences Earth on a more intimate scale, molecule by molecule, organism by organism. Let's start beneath the surface, beneath the skin, to be more precise. Human biology, much like plant biology, is solar-powered in more ways than one. When sunlight reaches human skin, it triggers the production of vitamin D, a critical compound for calcium absorption, immune function, and even mental health. A deficiency in this humble vitamin can lead to fatigue, weakened bones, and in some cases, depression. The irony is almost poetic. Sunlight that travels across space for minutes, birthed from reactions that take millennia, finally arrives to tickle the skin and start a chemical chain reaction that keeps bones from crumbling. But sunlight doesn't just stimulate vitamins, it also governs time within the body. Deep in the brain, in a structure known as the suprachiasmatic nucleus, lies our circadian pacemaker. This biological clock responds to light signals that enter through the eyes and keeps our sleep-wake cycles running on a roughly 24-hour rhythm. Without sunlight to anchor this clock, our internal timing would drift, making sleep unpredictable and potentially damaging to health. People who live in polar regions where the sun disappears for months at a time often suffer from a condition called seasonal affective disorder. This isn't just a poetic sadness brought on by endless night. It's a direct consequence of the lack of solar regulation in the brain. Artificial light can help, but it rarely replicates the full spectrum, intensity, and natural rhythm of sunlight. There's something ancient and deeply wired about our connection to the sun. Even before clocks and calendars, there was light and darkness. The alternation between the two was the first metronome, setting the tempo for life. Sunlight, in short, tells us when to wake, when to sleep, when to eat, and even when to heal. Research has shown that surgical patients exposed to natural light tend to recover faster and require less pain medication than those kept under artificial lighting. Schools with access to daylight see improved test scores among students. In prisons, exposure to sunlight has been linked to better mood regulation. The sun doesn't merely sustain us biologically. It shapes our behavior, our learning, our healing, and our mood. But beyond the body, the sun also dances with the mind. Artists, philosophers, and poets have long revered sunlight as a symbol of clarity and revelation. From the sun gods of ancient Egypt to the stained glass beams of medieval cathedrals, sunlight has represented everything from truth to divinity. But you don't have to be religious or artistic to feel this. Step into a sunlit forest or walk into a room bathed in morning light, and your brain responds with a quiet rush of serotonin, the neurotransmitter associated with happiness. Evolution rewarded creatures that basked in the sun because the sun meant food, safety, and warmth. Yet the sun's influence stretches even further. It doesn't just shine on us, it shapes the entire planetary environment. The atmosphere itself, with its layered complexity, would not exist in its current form without solar radiation. The ozone layer, the thin shield of gas that absorbs most of the sun's ultraviolet radiation, is a direct response to the sun's energetic assault. Without it, Earth's surface would be scorched by UV rays, and most life as we know it would be impossible. Then there's the ionosphere, a region of the upper atmosphere that becomes charged by solar radiation. This layer reflects and modulates radio waves, allowing long-distance communication across the globe. Every time you tune into a faraway station or send a signal bouncing across continents, You're depending on the sun's interaction with Earth's upper atmosphere. And of course, solar storms, massive eruptions from the sun's surface, can send pulses of charged particles hurtling toward Earth. These aren't just pretty light shows. They can scramble satellites, disrupt power grids, and confuse GPS systems. In 1989, a solar storm knocked out power across Quebec. In 1859, the Carrington event, a particularly intense solar flare, set telegraph wires ablaze and caused auroras visible near the equator. While these are rare, they remind us that the sun is not a gentle ornament, but a dynamic and sometimes volatile force. Auroras themselves are an elegant reminder of this relationship. When charged particles from solar storms collide with Earth's magnetic field, they funnel toward the poles, colliding with atmospheric gases and releasing energy in the form of light. Greens, reds, purples, they shimmer in the sky like silent fireworks. These natural spectacles are not just beautiful. They are direct evidence of our planet's protective bubble interacting with the fierce energies of its star. The magnetic field of Earth, shaped by its spinning core, acts like a shield. But it wouldn't need to exist in this form if not for the sun's persistent assault of solar wind. Every second, a stream of charged particles flows from the sun in all directions. This solar wind would strip away the atmosphere of any planet that didn't have a protective magnetosphere. Mars, once rich in atmosphere, likely lost much of it because it lacks such a shield. Without its magnetic armor, Mars was exposed, and over eons it became a barren desert. Earth, by contrast, has held on to its air and its water. Thanks in Part 2, this magnetic protection, shaped and stimulated by the sun itself. In a cosmic sense, the sun challenges the planet, and the planet responds with ingenuity. Oceans, forests, and life arising in the spaces where energy meets balance. Even the Earth's rotation and orbit are tied to the sun. The gravitational tug from the sun keeps Earth moving at a speed of nearly 30 kilometers per second. That's roughly 100,000 kilometers per hour. This motion, combined with the axial tilt, creates seasons, solstices, equinoxes, and the changing patterns of weather. The sun doesn't just shine, it orchestrates the calendar. Think of solar eclipses, those rare moments when the moon perfectly aligns between Earth and the sun, casting a shadow across the planet. These events remind us of how precisely our solar system is choreographed. The moon is 400 times smaller than the sun, but also 400 times closer to Earth, making them appear nearly the same size in the sky. During an eclipse, as daylight dims and animals fall silent, we feel the sun's absence in a way that no science textbook can describe. It's a visceral moment of awe, a break in the rhythm that makes us realize just how essential sunlight is, even when we're not consciously aware of it. Throughout history, solar cycles have even influenced climate. The Maunder minimum, a period of low sunspot activity in the 1600s and 1700s, coincided with what's known as the Little Ice Age in Europe, a time of colder winters and shorter growing seasons. Though the exact mechanisms are complex, it's clear that fluctuations in solar output can ripple across the globe, affecting agriculture, migration, even political stability. In subtle ways, the sun has shaped history as much as geography or technology. In modern times, we've started to learn how to capture solar energy directly, converting sunlight into electricity through photovoltaic cells. Solar panels, once novelties, now cover rooftops and stretch across deserts. In 1 hour, the sun delivers enough energy to Earth to power all of humanity's needs for an entire year, if only we could catch it all. This shift toward solar power is not just practical, it's poetic. It represents a return to the original source, a recognition that the energy we extract from coal and oil was once sunlight trapped in ancient forests. Solar power is not new. It's a rediscovery. The sun keeps Earth alive not through brute force, but through balance. provides just enough energy to sustain life, not too much to incinerate it, and not too little to let it freeze. It nudges the planet into just the right orbit, encourages the right chemical reactions, and whispers the right cues into every cell. All of this without a single conscious thought. The sun is not alive in the way we are, but it is the cause of life in every sense that matters. In the end, whether you're lying in a field, watching clouds drift by, or curled under blankets listening to the sound of distant thunder, you are part of a grand system powered by a ball of plasma so vast it could fit 1 million Earths inside. And yet, despite its scale and distance, the sun feels personal. Because without it, there would be no you to consider these things. There is a quiet symmetry in how the sun's presence echoes through every corner of life. From the towering trees in a rainforest to the silent microbes nestled in Antarctic ice, everything is touched, shaped, or sustained by sunlight. The power of the sun is not only that it illuminates, it activates, it organizes, it sustains. It gives matter its marching orders, telling atoms when to bond, molecules when to break apart, and cells when to replicate. Take the ocean, that vast mirror reflecting the sky. The uppermost layer of the sea, called the euphotic zone, is penetrated by sunlight. In some of the clearest ocean waters, light can reach down to about 200 meters. Within this shimmering realm, microscopic organisms known as phytoplankton perform photosynthesis. Though invisible to the naked eye, they generate more than half of the Earth's oxygen supply. They are the lungs of the planet, floating on waves, powered solely by sunlight. A single milliliter of seawater can contain thousands of these tiny organisms. As they convert sunlight into energy, they not only feed entire food chains, but also absorb vast amounts of carbon dioxide. In doing so, they play a role in regulating global temperatures and carbon cycles. Without sunlight, these microscopic guardians would vanish, and with them, a balance that keeps the entire Earth's atmosphere breathable and temperate. Beneath the surface of the land, in forests and fields, a similar process unfolds. Leaves open to the sky like tiny solar panels, gathering light not just to feed themselves, but to nourish entire ecosystems. The energy captured by one plant feeds an insect, which in turn feeds a bird, and so on. Each step in the food chain is an echo of a photon that left the sun minutes earlier and crashed into a leaf at just the right angle. Photosynthesis is one of the most efficient transfers of energy in nature. About 1% of the sunlight that reaches a leaf is converted into chemical energy. That might seem small, but when multiplied by the billions of leaves on billions of trees across the globe, it becomes an unstoppable engine. Every apple, every ear of corn, every grain of rice owes its existence to this silent transaction between sunlight and chlorophyll. Animals, too, respond to sunlight in subtle but powerful ways. Migratory birds navigate using the sun's position, adjusting their path with a precision that rivals any GPS. Sea turtles, after hatching, orient themselves toward the brightest horizon, which is usually the open ocean illuminated by the moon reflecting sunlight. Even certain fish adjust their depth in the water column based on solar position, seeking warmth or avoiding predators. Reptiles bask to regulate their body temperature. Butterflies align their wings to capture heat, and flowers track the sun across the sky in a gentle pirouette known as heliotropism. Sunflowers are perhaps the most famous example. Young plants literally turn their faces from east to west, following the sun's arc. This isn't a poetic metaphor. It's a mechanical, biological response, guided by growth hormones that elongate cells on one side of the stem faster than the other. But it's not just the natural world that follows the sun. Human civilization is deeply solar in nature. From the earliest sundials to modern clocks, we have measured time by the sun's passage. Our calendars, religious festivals, and cultural rhythms have all been tethered to the solar cycle. Ancient civilizations built monuments aligned with solstices and equinoxes. The pyramids of Egypt, Stonehenge in England, the temples of the Maya, all built to honor and harness the sun. These weren't mere aesthetic decisions. Aligning with the sun helped determine when to plant crops, when to prepare for winter, when to harvest. The agricultural revolution that enabled civilization was ultimately a solar event, with predictable seasons made possible by Earth's orbit and tilt relative to the sun. Humans could stop roaming and start farming. The sun made settlement viable, and in doing so, gave rise to towns, cities, governments, and cultures. Even architecture reflects this legacy. In colder climates, buildings are designed to capture and retain sunlight. In warmer regions, they are built to reflect it or allow for cooling airflows. Modern sustainable design often includes solar orientation, skylights, and panels. The sun is not just an ancient deity of the past, it's a partner in our progress. And then there's time. Every day begins when sunlight returns. Every year starts when the sun reaches a particular point in the sky. The seasons turn, not because we tell them to, but because of Earth's tilt and its orbit around the sun. Without these movements, there would be no spring, no harvest, no cycle to synchronize with. Time itself, as we experience it, is born from our planet's changing angle to the sun. As Earth spins, the sun appears to rise in the east and set in the west. This apparent motion creates the day-night cycle, which in turn shapes everything from sleep schedules to work hours. In some parts of the world, where the sun never fully sets or rises for long stretches of time, this cycle becomes blurred, and the human body reacts accordingly. People become disoriented. Productivity shifts. Sleep patterns fragment. All of this is further evidence that our biology is not independent of the sun. It is synchronized with it. And then there's solar energy, our modern attempt to bottle the sun's power. Photovoltaic technology, which converts sunlight into electricity, is rapidly becoming one of the leading sources of renewable energy on Earth. 1 square meter of a solar panel under full sunlight can generate around 200 watts of power. Cover a rooftop, and you can power a house. Cover a desert, and you could power a continent. The beauty of solar energy lies in its elegance. There's no moving parts, no combustion, no emissions, just a surface that soaks in sunlight and releases electricity. It's not just efficient, it's poetic. The sun, which once fed crops, now feeds cities. The same light that once warmed a Stone Age hunter's skin now charges a satellite orbiting far above the clouds. Yet, even with all our technology, we still live under the sun's authority. Space missions are launched in windows that depend on solar alignment. Satellites need solar panels to function. Mars rovers stretch their limbs toward the sun to keep alive. Space stations track the sun to regulate power. Even beyond our atmosphere, humanity relies on the same light that filters through a bedroom window at dawn. But not all solar influences are gentle. The sun also has moods. Sunspots, dark regions on the surface, are cooler areas caused by magnetic activity. These spots often precede solar flares, intense bursts of radiation that can disrupt electronics, damage satellites, and endanger astronauts. The sun undergoes an 11-year cycle of activity, from quiet periods to solar maximums, when sunspots and flares become more frequent. Understanding this cycle is crucial for planning space missions, maintaining communication systems, and even predicting auroras. As our dependency on electronics grows, so too does our vulnerability to solar weather. A strong solar storm could, in theory, disable power grids, shut down satellites, and bring parts of modern life to a halt. That's not science fiction, it's a possibility. And it's one we're preparing for with monitoring satellites and forecasting models. And still, with all this raw power, the sun remains steady. For billions of years, it has blazed across the sky providing a level of reliability unmatched in the cosmos. Stars are often volatile. They can expand, collapse, or explode. But our Sun, a middle-aged yellow dwarf, is one of the most stable types in the universe. Its predictability is the foundation upon which every earthly system rests. Imagine, for a moment, what Earth would be without the Sun. Within a week, the surface temperature would plunge below freezing. Plants would die. Oceans would begin to freeze from the top down. Photosynthesis would stop. The food chain would collapse. Most life would vanish. Only some bacteria and extremophiles might cling to existence near geothermal vents. Earth would become a frozen echo chamber. It's vibrant. Chorus silenced forever. But the Sun is here. Today, tomorrow, for billions more years. Rising with mathematical certainty, casting shadows with precision, and energizing every breath, every bloom, every heartbeat. It is the quiet architect of balance. It doesn't demand attention, though it receives plenty. It doesn't claim credit, though it deserves it. It simply shines. While the Sun seems ever-present and dependable, its influence on Earth is dynamic and multi-layered. It doesn't merely shine from a distance. It integrates with every sphere of our planet's system. From the lithosphere that forms the solid Earth, to the atmosphere that blankets us, to the biosphere that teems with life, and the hydrosphere that flows and freezes. Each domain reacts uniquely to sunlight, making Earth a living, breathing composite of solar responses. Consider the atmosphere, the thin shell of gases that clings to Earth like skin. It acts both as a filter and a conduit for solar radiation. Ultraviolet rays, which are harmful in excess, are mostly absorbed by the ozone layer, which floats in the stratosphere between 15 and 35 kilometers above the surface. Without this protective screen, life would have had a much harder time emerging on land. With it, solar radiation is moderated, letting in just enough energy to support life while blocking the lethal doses. But not all sunlight is stopped. The visible spectrum, the gentle range of colors our eyes are tuned to, is allowed through with high efficiency. Blue light scatters more than red, which is why the sky appears blue during the day. As the Sun nears the horizon, sunlight passes through more atmosphere, scattering the shorter wavelengths and allowing the reds and oranges to dominate. The same scattering gives us the brilliant palette of sunsets, a daily masterpiece painted by solar photons interacting with air molecules and suspended dust. This same sunlight heats the surface unevenly, setting air masses into motion. Warm air rises at the equator and sinks at the poles, creating global circulation cells. These cells drive trade winds, jet streams, cyclones, and anticyclones. Without sunlight, there would be no winds, no storms, no weather. The churning chaos of the atmosphere, clouds that billow, storms that rage, breezes that whisper, are all orchestrated by the Sun's steady beat. Solar heating also fuels the water cycle. It evaporates moisture from oceans, lakes, and rivers. This vapor ascends, cools, condenses, and falls again as precipitation. A single thunderstorm can release up to 1.5 billion liters of water in the form of rain. Every droplet owes its existence to the heat of the Sun lifting water skyward before gravity brings it down again. This continuous loop fills aquifers, nourishes crops, carves canyons, and drives the slow march of erosion that sculpts mountains and valleys. In the cryosphere, the frozen domain of glaciers, snowfields, and polar ice, the Sun's reach is more subtle, but just as crucial. Ice reflects most incoming sunlight, helping regulate planetary temperature through a process known as albedo. When ice melts due to warming, more solar energy is absorbed by the darker water or land beneath, amplifying the warming in a feedback loop. This process accelerates the melting of polar regions, influencing sea levels, ocean circulation, and even the migration patterns of marine animals. In the lithosphere, the sun's effect is less direct but still profound. Surface temperatures dictate the expansion and contraction of rocks, leading to weathering over time. In deserts, the daily temperatures swing between sunlit heat and nighttime. Cold can cause rocks to fracture. Over centuries, this cycle breaks down mountains into dust. Even the soil under your feet is partly a product of solar-powered chemical reactions between minerals and moisture. Agriculture, perhaps the most obvious beneficiary of sunlight, has been fine-tuned by millennia of human observation. Farmers have long known how to read the sun, its intensity, its timing, its seasonal movement. Crop cycles are synced to the solar year. Even ancient plowing patterns aligned with solar angles. In modern times, satellite imaging uses reflected sunlight to assess crop health, monitor droughts, and predict yields with remarkable precision. The same rays that once warmed a farmer's back now inform data models and agricultural forecasts. Energy production, too, is deeply linked to the sun. Fossil fuels, coal, oil, and natural gas are essentially ancient sunlight. They formed from organisms that captured solar energy through photosynthesis millions of years ago. That energy was buried, compressed, and stored underground. When we burn fossil fuels, we are tapping into concentrated sunlight from a distant, geological past. Every engine turning, every light flickering is a whisper from ancient sunshine released in modern times. And now, with solar panels, we have returned to the source. Modern photovoltaic cells capture sunlight directly, converting photons into electrical current. A single panel under ideal conditions can produce over 300 watts of power. Scaled up. Solar farms stretch across landscapes, feeding cities with clean, renewable energy. Some nations now generate more than a quarter of their electricity from solar sources during peak hours. As technology advances, efficiency rises, and costs fall. Sunlight is once again becoming the world's most democratic power supply. Culturally, the sun remains central. Across civilizations, it has been worshipped, studied, and mythologized. The Inca revered Inti, the sun god, as the father of their empire. In Egypt, Ra sailed the sky each day in his solar boat. In Japan, the imperial family traces its lineage to Amaterasu, the sun goddess. These myths, while symbolic, reflect a deeper truth. Human beings have always known that their fate is tied to the movements of that burning orb above. Even in literature and art, the sun often symbolizes truth, power, life, and clarity. In paintings, it is the source of golden halos and dramatic shadows. In poetry, it is the eye of the day, the giver of warmth, the great revealer. It remains the backdrop of lovers' meetings, children's laughter, and epiphanies, great and small. It is not just a physical presence, it is an emotional one. And yet, for all its glory, the sun remains curiously indifferent. Thus, aimed to support life. It doesn't intend to warm or nourish. It simply exists, a nuclear reaction suspended in space, obeying the laws of physics. Its role as life-giver is a coincidence of chemistry and distance. A little closer, and Earth would bake. A little farther, and it would freeze. But here we are, suspended in a cosmic sweet spot, orbiting a star that neither notices nor cares, and yet gives us everything. That balance, the precise tilt of Earth's axis, the exact shape of its orbit, the regulating role of its atmosphere, is what transforms raw sunlight into livable energy. A slight change in any one factor would alter the planet dramatically. If Earth's axial tilt were different, seasons would shift in length and intensity. If the orbit were more elliptical, temperature swings would be greater. If the atmosphere were thinner, solar radiation would bombard the surface. The climate of Earth is not an accident, but the result of these countless balances. An equilibrium maintained by the sun's energy and Earth's response to it. Climate scientists track solar irradiance, cloud cover, greenhouse gases, and albedo. levels to understand how stable this balance is. While the sun's output remains relatively stable, Earth's systems are changing, largely due to human activity. And this brings us to the pressing issue of climate change. Though the sun powers Earth's climate, human actions now influence how that energy is absorbed and retained. By adding greenhouse gases like carbon dioxide and methane into the atmosphere, we trap more of the sun's heat. The result is global warming, an intensification of the sun's influence amplified by artificial means. Sea levels rise. Storms grow stronger. Heat waves stretch longer. The sun itself hasn't changed, but Earth's relationship with it has. Solar studies now play a vital role in climate modeling. Satellites measure solar irradiance. Observatories track sunspot activity. Instruments aboard spacecraft like the Solar and Heliospheric Observatory collect data on the sun's magnetic field. Understanding the sun is not just about knowing our star, it's about forecasting the future of our planet. And still, each morning, the sun rises. Predictably, faithfully lighting up cities, warming oceans, waking birds, nudging flowers into bloom. Its light touches mountaintops and seafloors, deserts and forests, glaciers and coral reefs. It falls upon the face of every child and every elder, on fields ripe with wheat and factories humming with machines. It powers satellites in orbit and algae in a puddle. The sun is our clock, our engine, our furnace, our painter of skies. It is the beating heart of the solar system, the keeper of time, the giver of rhythm. Without it, the Earth is silent. With it, the Earth sings. As the sun pours its radiant energy over Earth, the effects ripple outward. Not just across ecosystems, but into every discipline of science, every element of culture, every habit and instinct of every creature that walks, swims, flies, or grows. Its influence isn't static. It transforms. It shapes possibilities. It draws boundaries between what can live and what cannot. And most profoundly, it shapes what we can know, because even knowledge itself has grown under the light of the sun. Take astronomy, for instance. The sun was our first astronomical subject. It was the first celestial body we tracked, the first to become a reference point for timekeeping and navigation. Long before telescopes existed, people built observatories aligned with solar cycles. Not because they understood the sun, but because they understood that their survival depended on its patterns. They watched its rising point drift northward and southward across the horizon over the course of a year, learning to predict seasons and harvest times. In the Middle Ages, scientists like Copernicus, Kepler, and Galileo reoriented our understanding of the cosmos by placing the sun, not Earth, at the center of the solar system. This change wasn't merely astronomical. It was philosophical. It dethroned human ego. It reshaped religious belief. It planted the seed of scientific revolution. And it all began with the realization that the sun was not revolving around us. We were revolving around it. Today, we've turned our instruments back toward the sun, not out of worship, but out of curiosity. Observatories on Earth and satellites in orbit monitor solar flares, track coronal mass ejections, and measure the sun's magnetic field. The Parker Solar Probe, launched in 2018, is flying closer to the sun than any spacecraft in history, passing through its outer atmosphere to gather unprecedented data. It was built with heat-resistant materials, traveling at speeds up to 700,000 kilometers per hour, all to get closer to the source of everything we know. And what we've learned is that the sun is anything but simple. Surface, or photosphere, is a turbulent arena where hot gases rise and fall in vast loops. The temperature here hovers around 5,500 degrees Celsius. But oddly, just above that, in the corona, temperatures soar to over 1 million degrees. It's a paradox. How can it be hotter farther from the heat source? The answer may lie in complex magnetic fields that twist and snap, releasing energy in bursts more powerful than 10 billion nuclear bombs. These magnetic fields drive solar storms. When a solar flare erupts, it sends waves of charged particles into space. If directed toward Earth, these particles can interact with the magnetosphere, producing auroras but also threatening satellites and power grids. Engineers must consider solar activity when designing spacecraft. Airline routes over polar regions may be redirected during strong solar events. Even astronauts aboard the International Space Station take shelter in shielded compartments during solar outbursts. All of this means the Sun, for all its nurturing light, also holds the capacity to disrupt. It is neither benevolent nor malevolent. It is simply powerful. And Earth's defenses, its magnetic field, its atmosphere, must work in concert to shield life from the worst of its parent star's tantrums. But even in its most violent expressions, the Sun fascinates. Sunspots. Those dark, cooler patches on the Sun's surface have been recorded for centuries. Ancient Chinese astronomers documented them as early as 364 BCE. Sunspot counts help. U.S. track solar cycles, which peak approximately every 11 years. During a solar maximum, sunspots and flares become more frequent. During a minimum, solar activity quiets. These cycles affect everything from satellite communications to climate models. And speaking of climate, the Sun plays a nuanced role. While its total output doesn't vary dramatically, even small changes can influence Earth's climate. During the Maunder Minimum, a prolonged sunspot drought between 1645 and 1715, parts of Europe experienced colder winters, leading to crop failures and social unrest. Though greenhouse gases are the primary drivers of today's climate change, scientists continue to monitor solar irradiance to understand its subtle contributions. More than just a source of energy, the Sun is a laboratory. Within its core, the same nuclear fusion reactions that power hydrogen bombs occur in a stable, continuous loop. Scientists study the Sun to understand how stars form, live, and die. By analyzing the solar spectrum, we learn what elements exist not only in the Sun, but in other stars. Every spectral line is a clue. Helium, for example, was discovered in the solar spectrum before it was ever found on Earth. Solar neutrinos, elusive particles produced during fusion, stream from the Sun by the trillions every second. They pass through your body without interaction, almost entirely undetectable. Scientists build vast underground detectors, shielded from other radiation to catch just a few. These ghostly messengers confirm our understanding of the processes at the Sun's core, offering a glimpse into the otherwise inaccessible heart of a star. The Sun is also the key to understanding space weather. Unlike terrestrial weather, which changes day to day, space weather refers to the conditions in space affected by the Sun's activity. Solar winds, constant streams of particles, interact with Earth's magnetic field, shaping the radiation environment through which satellites must travel. A single intense storm can degrade communication systems, affect navigation, and pose radiation risks to astronauts. Understanding space weather is essential for space exploration and for protecting our modern technological infrastructure. And let us not forget the auroras, those breathtaking curtains of color that ripple across polar skies. These lights are the visual poetry of the Sun's interaction with Earth's magnetic cloak. As solar particles are funneled toward the poles, they collide with atmospheric gases, exciting them into glowing. Oxygen produces green and red hues, while nitrogen glows blue and purple. The resulting display is more than a spectacle. It is a visible reminder that Earth and Sun are not separate entities, but deeply entwined. This entwining extends even to the formation of our planet. The early Sun, young and tempestuous, blasted the inner solar system with solar wind. These forces helped shape the orbits of planets, clear away excess material, and influence which elements remained close to the star. Earth formed within this cauldron of radiation, gaining mass, crust, and eventually atmosphere, all under the influence of solar energy. The early Earth was bombarded not just by comets and asteroids, but by intense ultraviolet and X-ray radiation from the young sun. This might seem hostile, but it could also have been catalytic. Some theories suggest that solar radiation helped drive the chemical reactions that led to life itself. The formation of complex organic molecules, amino acids, nucleotides, may have been triggered by energy from the sun interacting with gases in Earth's primitive atmosphere. If so, then the very spark of life was solar. Even today, the balance between solar energy and Earth's own internal processes defines our planet's surface conditions. Earth's internal heat powers, volcanoes, plate tectonics, and geothermal vents, but the atmosphere, oceans, and climate are sculpted by solar input. The interface between solar and terrestrial energy is where we live. We are creatures of that edge, walking a boundary line between deep Earth heat and distant starlight. And so, from the micro to the macro, the sun continues to influence every process on Earth. Its photons become food. Its radiation becomes information. Its presence becomes meaning. It sets the rhythm of life, regulates our biology, inspires our art, and propels our science. It is not a distant observer. It is a participant in everything. Even now, as you sit under artificial lights or behind shaded windows, your body remembers sunlight. Your circadian clock is still ticking to solar cues. Your skin cells retain the imprint of photons. Your thoughts, your memories, your sense of time, they are all calibrated, however subtly, by the presence and absence of light. The sun does not just keep Earth alive in the biological sense. It animates Earth with seasons, with energy, with purpose. And in return, Earth reflects that energy outward, not just in light, but in life. To say the sun keeps Earth alive is both a statement of physical reality and a metaphor for the intricate relationships that sustain existence. It doesn't merely power photosynthesis or warm the planet. It weaves itself into the physics, chemistry, and psychology of life. It is etched into the DNA of every organism, into the seasonal migrations of animals, into the myths of civilizations, and into the electric pulses that govern the human heart and brain. There is no escaping it. There is only adapting to it, learning from it, and depending on it, utterly and unconditionally. Let's revisit the idea of the sun as the ultimate metronome. Its rhythms aren't limited to days and nights. It also dictates the tempo of the year. The axial tilt of the Earth, about 23.5 degrees, ensures that the sun's rays strike different parts of the globe at different angles over the course of our orbit. This creates the seasons, but the way those seasons manifest is deeply complex and varies dramatically from equator to pole. Near the equator, where sunlight is consistent year-round, there are wet and dry seasons rather than the classic four-season model. Here, agriculture and animal behavior are tuned to rainfall, which is ultimately driven by solar heating of ocean currents and atmospheric patterns. Farther north and south, solar angles change more dramatically across the year, giving rise to spring, summer, autumn, and winter. Plants bud and fruit in tune with these shifts. Animals breed, migrate, or hibernate based on the lengthening or shortening of days. Human culture, too, is season-bound. Our calendars, holidays, and even diets have evolved around solar cycles. Traditional societies marked solstices and equinoxes with rituals and feasts. In modern times, entire economies rise and fall with seasons, tourism, agriculture, retail, all shifting in response to the dance between Earth's tilt and the sun's light. But the sun's rhythm goes deeper than seasons. It also touches geological timescales, Milankovitch cycles, long-term changes in Earth's orbit and axial tilt alter how much solar energy the planet receives over tens of thousands of years. These cycles help explain the timing of ice ages and interglacial periods. When Earth's orbit becomes more elliptical or its tilt increases, solar radiation patterns shift, leading to slow but profound climate changes. Ice sheets grow and recede. Ocean levels fall and rise. Habitats migrate across continents. The sun even defines the very shape of time we perceive. Before mechanical clocks, the sun governed daily life. Noon was when the sun stood highest in the sky. Time zones were eventually created to standardize this experience, but they are artificial overlays on a solar truth. A solar day, the time between two solar noons, slightly fluctuates throughout the year, which led to the development of mean solar time to regularize daily schedules. Even our atomic clocks, the most precise timekeepers ever built, are still synchronized with the rotation of a planet governed by sunlight. There's an elegance to this structure. The fact that your morning alarm aligns with a star's motion is a kind of cosmic poetry. Every morning routine, every cup of coffee, every sleepy commute begins not with a smartphone's chime, but with the rising of a star. And yet, for all its constancy, the sun also changes. It is not frozen in time. It is slowly evolving. Each second, it converts about 600 million tons of hydrogen into helium. In the process, a small fraction of that mass is converted into energy, a process that keeps the sun shining. Over time, as more hydrogen is fused, the sun's core changes composition, causing the outer layers to expand and brighten. The sun is slowly growing more luminous. Scientists estimate that the sun's brightness has increased by about 30% since its formation 4.6 billion years ago. That's right. When Earth was young, the sun was dimmer. This poses an intriguing paradox. How did life arise under a weaker sun? The answer likely lies in a thicker greenhouse atmosphere that trapped more heat, balancing the reduced solar output. This is a reminder that life doesn't just passively receive the sun's energy. It adapts and responds in sophisticated, planet-wide feedback loops. In another 1 to 2 billion years, the sun will be too bright and hot for Earth to support life. As we know it, the oceans will evaporate. The atmosphere will disintegrate. Eventually, the sun will exhaust its hydrogen fuel, expand into a red giant, engulf the inner planets, and then shed its outer layers, leaving behind a white dwarf. Earth may be long gone by then, but the story of the sun will continue. And still, today, the sun is a quiet presence. It rises each day with dignity. It stretches shadows across floors. It fills windows with warmth. It animates colors. It nourishes skin. It turns dew to mist. It bakes sand, warms seashells, and softens ice. On cold mornings, it hums at the edge of hearing, a vibration through the entire solar system. We feel it even when we cannot see it. On cloudy days, its filtered light still regulates mood and growth. At night, its reflected light from the moon gives shape to darkness. Even starlight, the pale glimmers of other suns, remind us that our own is part of a wider stellar family. Every star is a sun to someone. Ours just happens to be perfectly placed. It is hard to overstate how lucky this placement is. The sun's size, mass, age, and distance from Earth all align with extraordinary precision. Too massive, and it would burn too hot and too fast. Too small, and it wouldn't generate enough energy. Too young, and it would be unstable. Too old, and it would be fading. But here it is, in its calm middle age, burning steadily, generously, benevolently. We are, in a sense, basking in the prime of our star's life. The sun also serves as a model. Scientists study it to understand other stars. They compare solar spectra with that of distant suns, looking for patterns. They model solar dynamics to predict how other systems might evolve. In this way, the sun is our touchstone. It helps us understand the structure of the galaxy, the life cycle. of stellar bodies, and even the probability of life elsewhere. If life can thrive under a star like ours, then perhaps it can thrive elsewhere too. There's also something reassuring about the sun's silence. It doesn't flicker with uncertainty. It doesn't tremble with fear or rage. It burns, it sustains. It pulses with energy that we measure but do not control. It operates on a scale that humbles. Its lifespan stretches over epochs, while we count days. Its light has seen continents shift, species rise and fall, oceans open and close, and still. It shines, it asks for nothing, it makes no demands. It simply is. And yet, without it, everything collapses. Every meal, every breath, every heartbeat, every memory, every language, technology, story, and dream. Every footprint in the mud, every glass of water, every raindrop on a leaf. None of it exists without solar energy. The sun is the unseen character. In every story, the silent witness to every history, the background actor in every moment, and the stage lighting that reveals the drama of life. Even sleep, when the conscious mind folds into rest, is regulated by the solar cycle. Melatonin, the hormone that signals sleep, begins to rise in darkness and falls with the return of light. Circadian rhythms aren't suggestions. They are commands from the sun, written in chemistry. The very idea of night, of dreaming, of rest, is shaped by an absence of light and by the certainty that it will return. The sun makes sleep possible, and it makes waking meaningful. When you wake in the morning and the sun's light trickles through your window, it's easy to take that light for granted. It feels automatic, as if it simply happens, like flipping on a switch. But that gentle beam of light traveled an incredible 150 million kilometers to reach you. It left the sun's surface about 8 minutes ago, but its journey didn't start there. That photon, one tiny parcel of energy, was born in the sun's core over 100,000 years ago. In that core, nuclear fusion occurs at immense pressure and temperature, generating light and heat. The energy produced there doesn't zip straight to the surface. It bounces. It ricochets from atom to atom, moving slowly through the dense solar interior in what scientists call the radiative zone. The journey is not linear. Single photon can take tens or even hundreds of thousands of years to escape this labyrinth, making the path from the core to the surface a kind of cosmic maze. By the time that photon reaches the photosphere, the sun's visible surface, it bursts forth into space, traveling the final leg of its long voyage in just over 8 minutes. Before brushing against your skin, glinting off a window pane, or being absorbed by a leaf. This delay between creation and arrival means that every ray of sunshine warming your face today began its journey before humans had built their first cities, before we had written a word, before the invention of farming. That kind of timeline gives the sun a strange, paradoxical identity. It is both ancient and immediate. Its energy is old, but its effects are fresh, touching the world anew every moment. The sunlight on your hand was made in a past so distant it outdates history, but it's only now completing its delivery. And once that energy arrives, it doesn't stop moving. It's absorbed, reflected, refracted, and converted. A single photon may strike a leaf and help power the creation of glucose in a plant. That glucose may feed an animal, which in turn feeds another. One unit of solar energy may change hands dozens of times as it cycles through the food web, the economy of life. Or that photon might strike the surface of asphalt, warming it and slightly altering the movement of air above it, influencing local weather patterns. In this way, sunlight not only sustains life, it shapes complexity. The chaotic movements of air, the interlocking of ecological networks, the flows of water and carbon, all of these are energized by the sun. Without its input, complexity would unravel. Order would degrade into stasis. Nothing would grow, nothing. would circulate and nothing would change. Even the Earth's rotation, while not directly caused by the sun, is revealed by the sun's motion across the sky. Our sense of east and west, of morning and evening, is based entirely on solar position. Long before compasses or satellites, people oriented themselves using the sun. It was the first compass needle, the first map. The shadows it cast told us where we were and what time it was. Entire navigation systems were based on tracking the sun's arc, allowing explorers to cross seas and deserts long before digital instruments. Today, we still rely on solar data to navigate the skies. Pilots, spacecraft engineers, and satellite operators depend on models that include solar radiation, solar storms, and light positioning. The global positioning system, which guides millions of people every day, depends on satellites powered by sunlight orbiting a planet lit by the very star they use to operate. The sun's presence is so deeply embedded in our technology that it often goes unnoticed. Solar panels, power calculators, rooftops, factories, even villages. Passive solar heating reduces energy needs in buildings. In some countries, solar water heaters are standard features in homes. Streetlights in remote areas run on solar cells. Entire highways are now being designed with embedded solar surfaces that produce electricity as vehicles pass overhead. In agriculture, solar radiation data helps farmers choose when and where to plant. It informs decisions about irrigation, fertilization, and harvesting. In medicine, exposure to sunlight helps the human body produce vitamin D, essential for bone health. Lack of sunlight has been linked to seasonal affective disorder, a form of depression that occurs during the darker months of the year. Light therapy, mimicking the effects of sunlight, has become a treatment for people in places where winters are long and dim. Even architecture has embraced solar design, with buildings now constructed to maximize natural light, reduce energy consumption, and improve mental well-being. Schools, hospitals, offices, and homes are being built to capture the psychological and physical benefits of sunlight, proving that the sun is not just a distant ball of gas, but an active participant in human comfort and happiness. And in art, sunlight continues to be one of the most important and symbolic tools. Painters have used it to create shadow, mood, and meaning. Filmmakers rely on golden hour, the short period after sunrise or before sunset, for its soft, flattering light. Photographers chase the sun's angles. Architects use light shafts and reflections to make concrete come alive. Even poets and writers invoke the sun as a metaphor for revelation, warmth, hope, or the relentless passage of time. All of this because of one star. One modest, middle-aged yellow dwarf in the arm of a quiet spiral galaxy. But for Earth, it is everything. And still, the sun doesn't only give. It also protects. Its gravitational pull holds the solar system together. Without it, the planets would drift off into the void. Its heliosphere, a vast bubble of solar wind, acts as a shield against cosmic rays. These high-energy particles, originating from other parts of the galaxy, could pose serious risks to life and electronics. But the solar wind pushes many of them away, forming a protective layer that envelops not just Earth, but every planet in our neighborhood. Even when it acts up, sending flares, storms, and magnetic disturbances, the sun remains a kind of guardian. Its variability teaches us how stars behave. It helps us prepare for the risks of space travel. It sharpens our instruments, our theories, our awareness. It challenges us to study, to monitor, to imagine, and predict. And in doing so, it becomes not just an object of observation, but a teacher. And like all good teachers, it gives us tools that extend beyond the classroom. Solar science has helped us understand other stars, discover exoplanets, and model stellar evolution. It has helped us build spacecraft, manage satellites, and even contemplate interstellar travel. Every probe sent into the outer solar system, carries power from the sun or knowledge made possible by studying it. It is the wellspring of the space age. In this context, the sun is more than just a physical necessity. It is a bridge. It connects us to the cosmos, to each other, and to the deep past. It reminds us of our origins and hints at our future. It shines on fossils and newborns, on ancient ruins and glass towers, on birds in flight and machines on Mars. It is the common denominator of experience on Earth, the one thing that touches all and spares none. And yet, for all its universality, the experience of the sun is deeply personal. The way it feels on your skin on a cold morning, the way it sparkles on a river surface, the way it slips through the leaves of a tree, creating dappled patterns. On the ground, these moments are small, but they root us in something vast. They remind us that we are not apart from nature. We are illuminated by it, warmed by it, timed by it, and made possible by it. The sun may be 1.4 million kilometers in diameter. It may sit 150 million kilometers away. It may weigh more than 99% of the solar system. But none of that changes the fact that, for each of us, it feels close. It feels immediate. It feels like home. It is the oldest friend we've ever had. The most consistent partner. The original rhythm of life. And still, the sun keeps giving. As it arcs across the sky each day, it plays a silent symphony that life has learned to listen to. Plants tilt their faces. Birds rise with song. Insects begin their buzz. People wake, stretch, and start again. It has always been this way. The sun does not ask for worship, and yet, from time immemorial, it has received it. Perhaps that's because, instinctively, humans recognize something profound. Without the sun, we are nothing. In the earliest human settlements, solar alignment was more than architecture. It was reverence. Stone circles, ancient pyramids, cliffside dwellings, all crafted with the path of the sun in mind. These were not simply observations of celestial mechanics. They were declarations of dependence. The people of those times might not have known about photons or nuclear fusion, but they knew enough to track the sun's return, to build monuments to its passage, and to time their lives by its rhythm. That same rhythm pulses in us still. Our sleep-wake cycles are synchronized to light and dark. Our hormone levels, blood pressure, and body temperature rise and fall in step with daylight. Our ability to focus, to be alert, to rest, all governed by exposure to the sun. People who spend long periods in darkness, submariners, Arctic researchers, spacefarers, report disorientation, mood swings, even cognitive changes. Artificial lights can help, but they're poor substitutes. The body knows. It waits for the real thing. And what is real sunlight, if not pure information? A photon is not simply energy. It carries data. It reveals, bounces off surfaces, carries their shape and color to our eyes, and gives form to the world. Without light, there is no vision. Without the sun, there is no visible reality. The human eye evolved under the guidance of solar light. Our perception of color is tuned to the sun's output. Even our emotional response to different times of day, the calm of dawn, the urgency of midday, the melancholy of twilight, is calibrated by solar intensity and angle. In this way, the sun doesn't just light the world. It defines how we see it, and perhaps how we feel about it. The sun also defines our relationship with time. Time is a curious thing, intangible, relentless, and invisible. And yet we count it, measure it, fear it, and chase it. And at the center of that chase stands the sun. Sundials were the first reliable timekeeping devices, and they didn't measure hours. They measured shadows. Time was once a visible thing, cast upon stone or sand, carved by the sun itself. Even today, in the age of atomic clocks and digital calendars, we mark time by solar movement. A day is one rotation of Earth relative to the Sun. A year is one orbit. A season is defined by Earth's position in relation to the solar angle. Without the Sun, time becomes abstract. With it, time becomes tactile, measurable, livable. And perhaps that is the Sun's most subtle power. It grants structure. In a chaotic universe, the Sun provides order. Gravity binds us to it. Light awakens us. Heat sustains us. Its cycles give us a sense of progression, birth, growth, rest, decay, all marked by light. Every stage of life is a solar note, played softly or boldly depending on where and when we exist. But the Sun is not static. It breathes in its own way. Its magnetic field flips polarity approximately every 11 years. During these solar cycles, its activity waxes and wanes. The number of sunspots increases, flares erupt, and solar wind intensifies. These cycles can have tangible effects on Earth. Geomagnetic storms that disrupt communications, heightened auroras, and subtle changes in upper atmospheric temperature. Yet these fluctuations are part of a larger constancy. The Sun's regularity is among the most stable known in nature. Across generations, centuries, even millennia, it keeps rising and setting with dependable precision. Its light, though made of countless chaotic interactions inside a nuclear furnace, reaches us with rhythm. And in this rhythm, we find stories. The Sun is a character in every tale of survival, every myth of creation, every farmer's almanac, and every child's drawing. It is a symbol as much as a star. In literature, it represents clarity, truth, life, and even the divine. In dreams, it can signal warmth or longing. In science, it is a model. In memory, it is a golden haze on summer skin, a shimmer on water, a slant of morning light across a bedroom floor. Even silence can feel solar. A still afternoon, filled with cicadas and the hum of distant heat, is a quiet given meaning by the Sun's presence. It is the backdrop to everything from childhood to civilization. And civilization in its modern form is increasingly aware of its need to return to solar roots. Fossil fuels, long relied upon to power machines and economies, are slowly being replaced. Solar energy is no longer a niche solution. It is becoming a central pillar. As panels become cheaper, more efficient, and easier to install, rooftops become power plants, vehicles become solar-fed, and regions once starved of electricity become electrified by sunlight. This return to the Sun is not merely practical. It is philosophical. It reminds us that the best solutions are often the oldest. The Sun is silent, inexhaustible, and free. It doesn't pollute. It doesn't divide. It doesn't arrive in barrels or depend on fragile supply chains. It simply appears, again and again, asking nothing in return. And yet, for all this simplicity, we are only just beginning to understand its depths. The Sun's surface is in constant flux, its corona a puzzle, its internal mechanics still not fully grasped. Helioseismology, the study of solar vibrations, has opened new doors into the Sun's interior, just as seismic waves tell us about Earth's core. But questions remain. What drives the solar cycle? How exactly does magnetic field reversal unfold? What role do nanoflures play in heating the corona? Every answer the Sun gives raises another question. It is a mystery wrapped in brilliance. It hides behind its own light, and light, it seems, is the final gift. For all the energy, heat, gravity, and magnetism, it is light that makes the Sun visible. It is light that paints the blue sky, that splits into rainbows, that draws shadows and highlights. Without the Sun's light, there is no color, no shade, no contrast, no vision. And without vision, how could we wonder? How could we dream? How could we imagine stars beyond our own? The Sun gives us more than survival. It gives us the impulse to look up. Ta! And looking up has changed everything. That simple, ancient act, tilting our heads toward the sun, narrowing our eyes at the light, became the first gesture of science, of curiosity, of reverence. Long before we split atoms or mapped genomes, we watched the sky. We marked the sun's position with sticks in the sand, with notches on bones, with temples carved from rock. And from those first skyward glances, a cascade of understanding began. The sun was the first mystery and the first answer. In many ways, it still is. Even now, in an age of computers and rockets, the sun holds secrets. We send probes into space and build instruments on mountaintops just to catch glimpses of its complexity. The Parker Solar Probe, now hurtling through the sun's corona, carries instruments designed to withstand temperatures over 1,300 degrees Celsius. The data it returns is already reshaping our understanding of solar wind and magnetic fields. Each time we learn something new about our star, it reflects not just a step in knowledge, but a leap in humility. Because to study the sun is to accept our limits. We can't touch it, can't go near it, can't fully replicate it. We build models, simulate plasma flows, analyze sunspot cycles, but the sun remains beyond us in a very real sense. And that, too, is part of its power. It invites awe. In an era where we so often expect answers, the sun reminds us that not all questions have simple ones. Yet for all its complexity, the sun's role remains remarkably clear. It is the cornerstone of Earth's energy system, the ultimate origin of wind, rain, waves, and warmth. Whether it's a tree growing in a forest or a child riding a solar-powered bus to school, the link to the sun is direct. Every breath we take, every calorie we consume, every footstep, every thought. They all begin with the light and heat streaming from a glowing ball of gas 150 million kilometers away. And so it's fitting that we have begun to turn to solar energy, not just out of necessity, but out of recognition. Recognition that the future we build must echo the balance the sun has always maintained with Earth: abundant, renewable, and patient. We are learning to design cities that harvest sunlight, vehicles that run on it, technologies that sip rather than guzzle its power. The sun doesn't demand extraction or combustion. It doesn't require pipelines or drilling. It simply offers, freely, quietly, every day. But while we embrace the future, it's worth reflecting on how far we've come and how much the sun has seen. The sun has watched over the birth of mountains and the crumbling of empires. It's seen oceans form and vanish. It's lit up the stone tools of early humans and the blinking screens of supercomputers. It has cast light on lovers and warriors, poets and scientists, children and elders. It has bathed dinosaurs in warmth and streamed through the windows of space stations. It is the one witness that never looks away. Its rays have traveled across battlefield and banquet, forest and freeway. They have bounced off snowcaps and steel towers. They have struck stained glass and mirrors, puddles and skyscrapers, the curved shell of a beetle and the metal skin of a rocket. And in every case, the light has done its work, warming, illuminating, revealing. And when the sun disappears from the sky, it doesn't leave us entirely. The moon shines with borrowed light. The planets gleam because of it. Even the faintest twinkle of starlight must pass through the night. Sky shaped by the absence of the sun. It defines both presence and absence, light and shadow. But it's not only the visible world that is affected. Deep within the brain, sunlight regulates melatonin, serotonin, and cortisol, hormones that shape emotion, motivation, and rest. Sunlight doesn't just light up the world. It lights up the mind. It impacts our sleep, our focus, our memory. It influences mood disorders, appetite, even immune response. A few minutes of morning sunlight can stabilize circadian rhythms for the entire day. And long-term exposure, or lack thereof, can shape a lifetime. And beyond physiology, there is psychology. There's something inherently optimistic about sunlight. Its return each day is a quiet reassurance that the cycle continues. That time moves forward. That night is not permanent. In the darkness of uncertainty, the rising sun is a constant. A cosmic reminder that even after the longest night, there is light. This sense of solar security has found its way into our language. We speak of sunny personalities, of bright ideas, of being enlightened. We associate light with clarity, truth, and goodness. And in many ways, these associations are not metaphor. They are the echoes of biology and experience. They are the human response to living in a solar world. And yet, it's easy to forget. Easy to treat sunlight as background. We build walls and roofs, spend hours under fluorescent lights, measure time in screens rather than shadows. But behind it all, the sun still rules. It pours through windows. It glints off pavement. It steers weather. It nudges leaves. It slips into photos and reflections. And even when we don't see it, it's working behind clouds, across oceans, halfway around the planet. To truly understand the sun is to see it not as scenery, but as substance. Not a background glow, but a generative force. It's not just up there, it's in here. In the warmth in your chest. In the light that reaches your eye. In the breath you just took, made possible by a photosynthesizing plant that drank in solar energy and gave back oxygen. You don't need to be a physicist or a farmer to appreciate this. Just step outside. Feel the warmth. Close your eyes. Listen to the world waking up. Everything you hear, smell, and touch is tuned to the sun. Even silence feels different in sunlight. And maybe that's the final lesson of our star. Not just that it gives life, but that it gives meaning. That it shows us a world not only full of function, but full of wonder. The sun doesn't just sustain Earth. It sustains curiosity. It fuels science. It frames beauty. It burns in our sky and in our imaginations. It is a reminder that the most powerful things in the universe often make no sound at all. That the greatest gifts do not arrive with noise or haste. They simply arrive again and again on time. And with every dawn, they begin again. The sun rises without fail. It does not wait for permission. It does not seek applause. It simply lifts itself above the horizon, pouring energy onto Earth with quiet precision. And with that one gesture, life is reignited. Trees begin their secret symphonies of growth. Flowers twist toward warmth like tiny satellites. Insects dart and birds lift. And somewhere, someone stands in the first light of morning, just breathing. This is the simplest truth of existence on Earth. It is solar. Not metaphorically, but materially. The sun is not a distant ornament hanging in the sky. It is the engine of reality. Its energy defines the difference between barren rock and a living planet. Between chaos and chemistry. Between cold silence and the chatter of ecosystems. Everything, absolutely everything, rides the currents of its light. It's in the energy trapped in fossils. It's in the muscles of a sprinting cheetah. It's in the rustle of wheat fields. In the swirling winds of a hurricane. In the gleam of oceans and the sparkle in a child's eye. That energy began in a dense, blazing core nearly 1.5 million kilometers wide. A constant nuclear reaction regulated not by machines, but by the sheer balanced physics of nature. And while the sun powers biology, it also powers meaning. Human history is solar history. Our cities grew where the light was generous. Our first great innovations, fire, farming, navigation, were all attempts to mimic, harness, or understand the sun. Even the earliest symbols carved in stone told solar stories. Spirals, circles, wheels, all echoes of that luminous disk that governed life below. We called it divine. We followed its path across the heavens. And even now, in an age of artificial lights and digital clocks, we still move to its rhythm. Our bodies are not confused. They still wait for morning. They still sigh at dusk. When we speak of saving the Earth, we are speaking of rejoining that solar rhythm. Fossil fuels are merely ancient sunlight stored in carbon bonds, released again in flame. But real sustainability lies in returning to the source, in tilting panels toward the sky, in engineering materials that drink sunlight, in buildings that open themselves to light instead of walling it out. To live sustainably is not to live with less, it is to live in alignment with the oldest pattern we know. The sun also humbles us. It reminds us that Earth is not the center of the universe, but a satellite in a system. That we do not control everything. That we are held in place by a gravity we do not feel. That light can travel for billions of years across space and still arrive. That warmth and life are possible in an otherwise cold, indifferent cosmos. It reminds us that every breath we take is borrowed from stars, that the carbon in our bodies was forged in long-dead suns, and that the star above us now is simply continuing the cycle. We are not just from the Earth, we are from the sky, and someday, far in the future, the sun will change. It will swell into a red giant. It will scorch the surface of Earth. It will scatter its outer layers and collapse into a white dwarf, cooling slowly over billions of years. But by then, we may have moved on, or evolved, or transformed into something else entirely. The sun's story is not over, and neither is ours. For now, we live in what scientists call the habitable zone. Not too hot, not too cold. The right distance for water to remain liquid and for life to flourish. This isn't a coincidence. It's a miracle of alignment. We orbit a stable star at the perfect range, with the perfect tilt, and the perfect mix of gases to trap and distribute solar energy. It is a cosmic jackpot. And we are the winnings. But what we do with that luck, that is still being written. So, next time you see a beam of sunlight slicing through a window, or dappling the forest floor, or dancing on the surface of a lake, remember, that's not just light. That's history. That's power. That's the fuel of life's crossing space. At the speed of light to touch your skin, warm your breath, and stir something ancient inside your bones. The sun doesn't need monuments. Every green leaf is already a cathedral. Every drop of water a shrine. Every heart beat a hymn. All it asks is that we keep orbiting, keep living, keep making something beautiful out of this brief moment under its gaze. So if you ever feel small or lost or uncertain, just step outside. Let the light fall on you. Stand very still. And remember, this star has always been here. Long before you. Long after you. But right now, in this one perfect moment, it is here for you. Thank you for watching this video. And once again, I apologize if it kept you awake or made it harder to sleep. Please feel free to like this video if you enjoyed it. Subscribe to the Sleepless Scientist channel for more calm science journeys. And let me know in the comments where you're watching from and what time it is for you right now. Now, if you're ready, the video will shift to a gentle soundscape, a quiet passage of natural ambient noise designed to help your mind unwind and drift toward rest. Until then, I wish you a peaceful evening, a calm mind, and a very good night.